All right, make sure that you have your notes out and go ahead and title them MSA number 4, Solving Equations. So you're going to be working on solving equations, and we're going to focus on the symbolic method, which is showing out all our steps and being able to solve equations without having the pouches and coins there, but going through a really specific method. And today you're also going to learn how to check your answer. Okay, so first thing I'd like you to write is your equation goal is to solve for the variable. You are always trying to get it alone. So the variable is usually like x or y or n or whatever it is. Your goal is to figure out what x is. So on one side of the equation, you want x all by itself. And then on the other side of the equation, you really want your numbers most of the time. Okay, so important, very important to write this down too. Whatever you do to one side of the equation, you must do to the other to keep it balanced. Okay, so if you do something to one side of the equation, you have to do it to the other as well. That's the only thing that's going to keep it in balance. Otherwise, it won't match each other anymore. Okay, we've been focusing a lot on equations that have multiplying and adding in them, but there's also a lot with subtracting and dividing. So I want you to keep this in mind. You want to undo subtracting with adding. You undo adding with subtracting, you undo multiplying with dividing, and you undo dividing with multiplying. So I would write all 4 of those operations down. And this is kind of the new part that we're going to be working on today, is always check your answer. So we're going to work through quite a few equations, and I want you to, in your notebook, in your graph notebook, write down each step. And then I'm going to ask you to write down your check too, and we're going to try to make this make more sense to you. We'll practice it a lot, but it's a very, very important skill. So, first equation that we're going to work on, here it is. Okay, 2x minus 1 equals negative 9. So you're going to notice that this is a little bit more complicated because it has negative numbers in it. It's not just adding, it has subtracting in there as well. So, new. You have not seen it when there's a minus 1 before, but remember, we're just trying to get it so just x's are over here and just numbers are on the other side. So if I want that minus 1 to go away, what do I have to do to make it get to 0? I need to add 1. Okay, so to undo minus 1, I'm going to add 1. Just like in before when you'd had like plus 3, you'd subtracted 3. When we have a minus 1, we add 1. And remember, I need to do the same thing to both sides of the equation. So if I add 1 to the left side over there, I need to add 1 to the right. So now I have 2x minus 1 equals negative 9, and I've added 1 to both sides. So important to note that when I had minus 1 and plus 1, those make 0. Those are gone. So on the left side, I just have 2x. And on the right side, I had negative 9. I added 1, so now I have negative 8. Okay? Now I'm getting to something that looks a little more familiar. I have 2x equals negative 8, so I had 2 pouches, and that's negative 8 coins or something. I'm going to divide to just figure out what's in one x. So I'm going to divide both sides by 2 in this case. And 2x divided by 2, that just gives me x. It's a negative 8 divided by 2, that gives me negative 4. Okay? So I think my answer is negative 4. What's going to be new today is I'm going to have to check it, and I'll show you how to do that. Okay, so when you check an equation, what you are doing is you're seeing if x does equal negative 4, does it really make this equation true? Do both sides really match? Kind of like when we plugged in some ordered pairs like 3, 5, and you were trying to see if x was 3 and y was 5, do both sides really equal each other or not? So here what I'm going to say is just x equals 4. So I'm going to go back to my original equation, and instead of x, I'm going to put in negative 4. So 2 times negative 4 minus 1, what I want to know, does that really equal negative 9 or not? Okay, to see if I got it right. So 2 times negative 4, that's negative 8. Negative 8 minus 1, that's negative 9. Negative 9 really does equal negative 9, what it was supposed to. So the two sides match, and I'm good. So that's how to check it. You plug in this answer, x, back in the original equation for x. You solve it all out and see if both sides actually match. Okay, let's try another one. It might be a little bit more complicated. Here it is. So x divided by negative 3 plus 5 equals 1. This tends to give people a little bit more trouble most of the time. I've noticed in the past because it's divided and You just haven't seen that much. So the first thing to keep in mind, I still am trying to get this x all by itself, okay? And I have divided by -3 and I have adding 5. The first thing I want to do is get rid of this plus 5. And just like we would have done before, I'm going to subtract 5 from both sides. Don't worry that you have a negative number over here. That's totally fine. So when I have x divided by -3 plus 5, and I've subtracted 5, these 5's cancel out. They're gone. All I have left on this side is x divided by -3. And here I had 1. I took away 5, so I have -4. Okay? All right, when I'm trying to get x all by itself here in this case, this is the first time you've seen this, the dividing here. Remember on the first slide, I said undo dividing with multiplying. Okay? So to divide by -3, to undo that, I want to multiply both sides by -3. So I usually put these in parentheses and I say I'm multiplying by -3. The good thing about multiplying by -3 is that, like, this is like -3 over 1. These cancel out. Okay, when I divide by -3 and then I multiply by -3, that's gone. That's why I wanted to do it, because I just get x now. And -4 times -3 is positive 12. So I've got x equals 12. I think that's my answer. And I'm going to ask you to check it again. So when I check it, I'm going to do this. I'm going to say if x really equals 12, so instead of x right here, I put in a 12. So I go 12 divided by -3 plus 5. What I want to see is, does that actually equal 1 or not? So I'm just going to solve out the left side using order of operations. 12 divided by -3 is -4. -4 plus 5, that's positive 1. And this side said it should equal 1, so it does. So I've checked it and it's right. Okay, what I'm going to write another problem up here that's similar to this, and I want to see if you can just try it on your own and see if you can get it. So here it is. X divided by 4 plus 6 equals 9. Well, let me make it a little more. Let me make it 8. Okay. X divided by 4 plus 6 equals 8. So I want you to try that on your own, then come back and see if you got it. Okay, since this tends to be hard for people. Okay, so I want to see if this is what you did. First, you should have subtracted 6 from both sides. And we should have on the left, it should have been x divided by 4 equals 8 minus 6, which is 2. Okay, now is x divided by 4, so to undo dividing by 4, I'm going to multiply both sides by 4. And remember, these 4's are going to cancel out. And I just have x equals 8. So I think x is 8. And if you checked it, I'm really happy with you. So when you check, you're going to put in 8 for x. I'm going to say 8 divided by 4 plus 6. I want to know if that really equals 8, which is my original equation. So 8 divided by 4 is 2. 2 plus 6 is 8. And I'm good. It worked out. So I'm happy. Okay. All right, let's try a couple more. So here it is. 5m plus 1 equals 7m plus 11. Try this one if you can on your own. But you might get stuck and have to refer back to this, but I would like to see if you can get it. Okay, so first thing I'm going to do, I personally, when I have variables on both sides, it doesn't matter that they're m, they could be x, whatever they are. I like to get rid of those first because I think it makes it a little bit more easy. So if I have 5m on the left and 7m on the right, I want to get rid of as many m's as match. So I'm going to say, I'm going to take away 5m from both sides. Because that's going to make it more simple. I'll only have m's on one side of my equation, which is good. Okay? If I had 5m on the left and I took away 5m, those m's are gone. I just have 1. 7m minus 5m, I still have 2m left, and I have 11. Okay. A lot of you might be really tempted to take away 1 from both sides because it seems easier. And you're allowed to do that, but then you have more steps. So my tip to you is try to get rid of the numbers that are with the variable. So I have 2m plus 11. It's going to be easier in this case if you get rid of 11 first. Okay, 1 minus 11 is negative 10. And just on this side, we only have 2m left because that 11 minus 11, those are gone. Okay, so I have a 2 with my m, and I want to get it alone, so I'm going to divide both sides by 2. Negative 10 divided by 2 is negative 5. 2m divided by 2 is just m, so I have negative 5 equals m. And then the last thing I need to do is see if both sides match. This one's more complicated because I don't have a number. So when I'm checking it, I'm putting in negative 5 for m every time I see an m, and this time it's twice. So I have 5 times m, which I think is negative 5, plus 1. I want to know if that's really equal to 7 times m, which 7 times negative 5, plus 11. So now this time I actually have to solve both sides out and see if they match. So 5 times negative 5 is negative 25, plus 1. And I want to know if that's really equal to 7 times negative 5, which is negative 35, plus 11. So negative 25 plus 1, that's negative 24. Negative 35 plus 11, that's negative 24. Okay, that's good because both sides equal each other. So I think m does really equal negative 5. Okay, let's do our last problem and see how you do. Okay, so this one, 3 times the quantity 2n plus 1 equals 15. This one looks tricky because it has parentheses in it. You're going to have to recall what you did with the distributive property. Okay, so way back when we were doing the algebra book, we learned how to use the distributive property to help simplify expressions. You have to use it to solve this equation, or you don't have to, but the other way is probably more complicated for you right now. So, distributive property says I take what's outside of parentheses and I multiply it by everything that's in the parentheses. So I'm going to take the 3 times the 2n, and that's 6n, and then the 3 times 1 is just 3. So now I have 6n plus 3 equals 15, and this looks like a much simpler equation for me to solve. Okay, so I'm going to go ahead and I'm going to subtract 3 from both sides to start getting my n's alone. Those 3 cancel, and I have 6n equals 12. And then lastly, I'm going to divide by 6, both sides, and I got n equals 2. Okay, so I want to check if this is right again, and when I check, I've got to be careful, and I need to make sure I use the original problem and not the one I worked out afterwards in case I messed up on the distributive property. So this says 3 times 2, and then in replacing n with 2 plus 1 equals 15. So I need to make sure I'm using my order of operations. So I'm going to work in the parentheses first and solve 2 times 2 plus 1. So 2 times 2 is 4 plus 1. That's 5. So I have just 3 times 5. I want to know if that equals 15. And lo and behold, 3 times 5 really does equal 15. So I'm done. Okay. I would like you to try one more problem on your own that has parentheses in it just to see if you can get that. So here we go. 5 times x minus 2 equals negative 20. Negative 25 I'll do. Negative 25. Okay. So try this one on your own, then come back and check and see if you got it. Okay, so first thing I'm doing distributive property. 5 times x is 5x. 5 times a minus 2, that's a minus 10. So 5x minus 10 equals negative 25. Okay, next thing I'm going to do, I want to get my x alone. It's minus 10 right there. To undo subtracting, remember I'm going to add. So I'm going to add 10 to both sides. These are gone. And I have 5x equals negative 15. So negative 25 plus 10 is negative 15. And then last, I'm going to divide by 5. And negative 15 divided by 5 is negative 3. So we have x equals negative 3. Okay, so if you got that, you're correct. I'm going to show you the check again, making sure that you do it with the parentheses and everything. So 5 times negative 3 minus 2, I want to know if that really equals negative 25. Negative 3 minus 2, that's like negative 3 plus negative 2, so that's negative 5. 5 times negative 5 is negative 25. That's what I wanted it to equal, so we're good. Okay, refer back to this at any time. Try to work on your worksheet, and the most important thing is showing all your work and showing your check. Okay, so we're going to be really focusing on the method this time, not just the correct answer.